Okay, stream should be live. Let's double check all the Twitch stats. Okay. I have a bit rate. Okay. Looks like everything is up and working. Cool. And hopefully this time with no weird technical shortcut difficulties. Wait a minute before I actually get started. See if anybody strolls on in. And if so, that'll give it a little bit better of a intro. But otherwise, I guess I can just start explaining things. I need a cool intro. I mean, I could do like, you know, this screen or something like that, but that's pretty boring. So I don't know what a cool intro would be. Oh yeah, I mean, I could have a verbal intro, but like, is there a point to an intro when I have nobody watching yet? You know. You know, that's the weird thing with Twitch. It's like you go live and you're like, huh, I literally have 0 people looking at this right now. I guess if I like scheduled times better with like Twitch's API and everything, it maybe would look a little better. But like, it feels weird to just give my intro before anybody's even arrived in the chat. But yeah, stats can lie. That's true. The API is not exact. But anyways, I'm Brendan, and let's get started. Oh man, don't have a good intro though. So goal for today is first to do a nice little explainer for people that's going to be on rock packaging, kind of how that works with the surgical linker. Because it's kind of the whole reason why we have these pain points, to be fair. And then I'm going to go into updating the basic CLI platform. And so when updating that, I'm just trying to like reduce the bloat a bit. And I've actually done a lot of precursor stuff to this, so I'll explain that and just lightly go over some of the history of the size of the binary. And the size of the binary if you download Rock today, which is big, to say the least. Really unnecessarily big. And then maybe I'll do the same for basic-webserver. Otherwise, energy permitting, which I can almost type words. I'm going to look into some of the llvm zig calling built-ins. But that would just be a basic introduction probably today. I doubt I'll actually get jumping into the code too much. Well, I mean, I'll have to show the code to explain what's going on, but that's the rough goal. And so I actually pre-made a little Excel draw here to explain kind of what Rock sees when it comes to compilation process. And as I said before, this is strictly for the surgical linker. But when we're looking at Rock's overall compilation process, it starts with a platform, because Rock kind of has this idea of like a swappable runtime, where each different application can pick its own runtime. And in this case, we call that a platform. And so in this bottom left corner, you can see how a platform is defined. A platform is a Rock app, and then also some sort of kernel, a host, as we call it, that's in another language. All of the most popular platforms right now are in Rust, and that's kind of what we supported at first, really just because the compiler's in Rust and we know Rust very well. But there's definitely a lot of interest in getting like a Zig platform or things of that nature. And so this is definitely going to expand. But currently there are examples of Ruby, of Swift, of Rust, of Zig, of C, of using Node.js through their C API, things like that. So like the platform can really be just about anything. And with the platform, the other part of it, besides just the host kernel, is a Rock wrapper, which is kind of where you define the full Rock interface. The first thing that we do is enable the host to pre-compile itself. And so we generate a shared library. It's just an empty dummy shared library. And the host compiler compiles an application that links against this shared library. And so essentially you have an application that expects to dynamically link to a Rock app plus this wrapper code. And this is what makes a package. And so like you can import a platform package for basic-cli for Rock web server. And if you look into it, it's going to be a bunch of .rock files and then a bunch of like executables essentially, or object files. Once we have this package, we go into step 2. And so for step 2, we take this package, we take the Rock wrapper library, we take the Rock application, feed those together through the Rock compiler to just generate a single object file. Now, probably in the future, that won't just generate a single object file, mostly because if you want to do things like incremental compilation and other tricks to make your compilation faster, trying to generate one final blob is actually pretty terrible. You'd much rather cut it up into a bunch of smaller blobs and then glue those together or something of that nature. And so we'll see how this transforms as we look into caching and other compilation related tricks to make things go faster. But for now, it just always generates this single object file. And then we have this magical tool called the surgical linker, which is basically a tool that takes something that wants a dynamic library and hacks on it until it accepts static code. And so that's exactly what happens here. We take this precompiled executable here from the platform. We then merge on the Rock object file, and now suddenly all of that stuff is statically embedded as opposed to needing to be dynamically linked at all, which gets you some performance benefits and also makes it so you can distribute as one single file without like any sort of weird dynamic dependency. And that generates the final Rock executable. This all works great. Not just in theory, but in practice, this actually works pretty well. We have it supported fully on Linux, and besides some minor edge cases, it just works. And the big gain from this is that you can link way faster. When we suddenly don't have to care about all of the dependencies that are in this host executable, we greatly simplify the problem. And so the problem now just becomes, for the surgical linker, how do you just add on a little bit of Rock code with no dependencies? Because Rock never has any dependencies. Everything is explicitly defined in the host that Rock depends on. And so like there's no, oh, let me search for some random thing in libc or dig in over here, etc. Instead, the surgical linker is able to run super fast because it just basically hacks a few little locations and updates a few, oh, the word's escaping me right now. It updates a few, relocations. There we go. That's what they're called. So it just updates a few relocations, and that's about it. After those relocations are updated, we're done. You know, the code's appended on the end, relocation's done, and we have a full executable. That's way less work than regular linking. And so instead of taking 100, 200, 300 milliseconds to link, we now can take 5 milliseconds, 10 milliseconds. You know, how fast is your disk? We can take that amount of time, right? And so it's this huge speed gain that like enables us to almost seem like a truly dynamic language, right? So like where Python, you know, you type into the REPL and go run and it runs and it's basically instantaneous. Rock can almost feel like that because the surgical linker is so fast and our compiler is pretty fast. Now it's not perfect yet and not always faster, but it is one of the ways we're pushing forward how fast you can do something. Now, switching to a minor drawback, because of this setup, the platform is a blob, right? It is this big blob with everything the Rock application might depend on. So we lose some of the tree shaking, essentially. Normally, when a linker does all its final linking, it's able to garbage collect and delete a lot of things. On top of that, a compiler, if it knows all of the dependencies, it can do its own tree shaking and delete things. And so when you look at a final Rust application, for example, it will delete a lot of stuff. Though, as we'll see, Rust still tends to be pretty bloated. It's a common known fact that Rust tends to be pretty bloated. So much so that there's a lot of websites dedicated to saying, here's how you get more minimally sized Rust. Here's how you deal with that problem and make your Rust applications similar to the size that C and Zig start with, right? But, you know, trade-offs. Rust decided to be this way, and for the most part, people don't care if an application is 5 megabytes or 100 kilobytes, and So Rust mostly is just fine with those larger sizes. Plus, if you really care, you can do some tricks to shrink the application size. In our case, when we originally set up the surgical linker, there were some minor problems with symbol exposure and things of that nature, and so we turned off Rust's ability to collect garbage. And so this was a huge problem. We finally returned that back on and fixed up some of our symbols and things of that nature. But with this off, we were essentially had a Hello World application that was 100 megabytes. And all of that 100 megabytes was random crap in Rust that just wasn't garbage collected. There was, a few kilobytes of rock code and 100 megabytes of garbage Rust that we didn't want. Now that we have the garbage collector on, this is a much better story. Immediately, you drop to something closer to that 5-ish megabyte size. Nonetheless, we'd like our applications to be really small if possible. And so given basic CLI is kind of our core application here, right? It is our main piece that we depend on. We want to try to shrink it down. And really the best way to shrink it down is probably to write it in Zig, I'm not gonna lie. But we're gonna shrink it down with the constraint that it is still built on Rust and has Rust trade-offs at the base. And so I've already done a little bit of work on that. And so if we come over here, okay, we don't need this screen yet. Give me 1 second. If we pop back to this view, if we look at basic CLI, really all I've done is, as I said, I turned back on garbage collection, which required me to make a few changes. That dropped it almost immediately from about 100 megs to somewhere in the 5 to 10 megabyte range. I then turned on just some recommended flags to help Rust realize what a good release binary is. Essentially, we're having Rust generate everything in single units using LTO and stripping debug info. And so all of that scrapes away a lot from this. What's the theoretical limit for a platform? Are you saying in terms of how small it could be? If you're saying how small it can be, I mean, what? Someone did a min-sized elf executable that's like a couple kilobytes, if I recall. And theoretically, a platform, is the min-sized elf binary plus a few extra system calls to deal with memory and things of that nature in a more complex manner. And so if you wanted like an absolute minimum platform that still exposed all of like your malloc, your free, let you use rock primitives, and then maybe just print it out as string at the end, my gut feeling is that if you really were trying to code golf it, you could still make that just a handful of kilobytes in size. Now, of course, that's a really restricted, not very useful platform. On the other hand, I think a more reasonable size for a nice platform that's kind of like a full-featured CLI, and we're actually trying to really slim it down at the same time, should be in the range of a few hundred kilobytes to maybe a megabyte, depending on how much it pulls in. Because as I said, we're still kind of restricted in some of the tree shaking that we wish we could do, but our current setup and linking model kind of blocks. And so that's what I would hope for. And currently with basic CLI, with this LTO and stripping debug info, I can actually show this now if I hit up a few times here. When this compiles right now, we're down to 3.6 megabytes. So this is worlds better than what it was before, because it was about 100, then it dropped to about 10, and then I turned on LTO and stripping of the debug info, and it now is down to this 3.6. And this is actually like a size that, honestly, I'd be comfortable shipping, but I still want to slim it down more. And so I want to show one thing. So in terms of basic CLI, there's not actually that many dependencies, but of course, dependencies are a bit of a lie, because this one dependency, request here, brings in an async runtime. It brings in a whole HTTP stack that depends on TCP. And, it brings in code for generating or for doing TLS. This is a very large dependency. That said, it's still compiling down relatively small. In fact, there's this really nice tool called cargo bloat. And so if I go back to this view here and I switch back to running cargo bloat on the binary, we see that for the most part, looking at this, it thinks that actually Rust code is the main code at this point. And then we have some from Hyper, which is what actually is doing the HTTP requests, some from generating TLS in Rust, right, as opposed to calling out to some native or C library. Not actually sure what H2 or Ring are, but I think they generally come with Tokyo. So I think this is all of the stuff for our async runtime, which is currently not even being used in this platform. It literally is just making a blocking call with an async runtime. It's not great, but this is something that we will need in the future when we enable the async behavior. It's just not enabled currently. And so according to this, request actually is only 100 kilobytes. When I checked this before doing LTO and doing the cogen unit restriction to only having one of them, request was about 800 kilobytes, if I remember. So it was about 8 times larger and was actually the biggest thing on this list. And so maybe request itself is not too bad. That said, we don't really need the features of request. We are just doing a basic HTTP client. And yes, I get that's what request is for. But why waste 100 kilobytes on it to make like one HTTP call when we can just use Hyper and see what size we get? And so first I want to just look at like how much size could we theoretically save with this binary? And so if I jump back over here to my old view, and we're just gonna remove request to start with, right? So if we remove request and then we come in here and we search for request, it's actually only used in this single function. So we should just be able to comment out all the code in this function. Of course, this is removing the feature to do any sort of HTTP requests. So it's not the final, what we want, but it gets us a baseline of some sort. And what we're just going to do here is just say it's unimplemented and let Rust compile this so that it would, panic if we ran into this. And so now if we compare the sizes, what do we actually get in terms of saving on this host binary if we remove request? And so I'm hoping that this is still a big savings. If it's not, I'll probably just switch to working on the basic web server platform, because I know that has much bigger savings to be got and to be done, versus this platform with LTO and everything else may not have as big of savings. Oh no, yeah, see, this is still huge savings. Excuse me. So if we could theoretically fully remove our HTTP stuff, we'd be down to 700 kilobytes. So that's 3 megabytes of savings, right? That's huge. Now, obviously, we're going to replace this with Hyper, which is what request is built on. So will that be any gains? Hard to say. So my first goal here is just to put like a dummy request in here that calls Hyper so that we can do some validation, just something super basic. And if that doesn't really shrink the size, this project isn't worth doing and we'll move on. If I can press buttons correctly. Okay. So I think in my web browser, yeah, I had opened up a few examples of doing different things. So this is actually, let me zoom in now that I think about it, make everything bigger. That was not the button I meant to click. There we go. Let me just go through my tabs, make sure all of them are at 150 so I don't forget later. I feel like that's a pretty reasonable size for the stream. There we go. Okay. Okay, so this here is actually what request does when you get to the deepest insides of it for a blocking request. And we're actually just gonna steal the base of it, more or less, I think. Specifically, we're just gonna steal using Tokyo runtime to send an HTTP request. But we're gonna use Hyper directly. And we're also gonna use Hyper rustls because we still would rather have a Rust dependency and embed a static TLS thing than have it depend on the system and maybe break at random times, because that just wouldn't be great. And so with that, let's just start by adding in the basic dependencies and maybe even looking at I think rustls should have an example, and we're basically going to copy its example to begin with. That'll tell us a lot. Of course, I'm on the feature flags page because that's the most useful page. No. I was on that page because I was trying to look at the idea of slimming things down even more. Do they actually have good documentation here? Yeah, they do. So we basically, let's just start with this and make sure this is full featured as the features we want and see what type of size it takes. Let me grab first this line for importing hyper, and we're going to actually remove some features. So we have hyper. I think the newest version is 27, so we'll grab that. No default features. We're not going to need the TCP feature, I don't think. We want HTTP 1 and 2, and we want to do client requests. I'm not sure if runtime's needed, so I'm pretty sure this is the minimal set of features for hyper that we can use. And then the other thing is hyper TL or rustls, which we can again just copy a dependency line for. Okay, hitting the wrong key. What? There we go. Okay. They just turn off all the default features. I don't know if that's safe to do, but I'm gonna trust them and just assume that I don't need any of those features for some reason. I mean, if request, which we used before, doesn't need the features, why should we, right? The other piece that I need is I want to make sure with the latest version. 24.2 is the latest. Okay. So that also can go up. Okay. So there you go. There are the dependencies. And then we just need to throw in a basic request here just to see, like, what does this pull in, if that's like what we're dealing with. So first, we don't want to use their Tokyo runtime like they define here. So I'm going to ignore that. Sure, we can grab these use lines, just follow along. So we have hyper. For now, we'll just grab some arbitrary URL, that sounds good, and set up HTTPS as they define it. Though I won't quite do it the same. I think there's this other function, I think, which is like enable both or something, because we want to be able to do both HTTP 1 and 2. We don't want to restrict ourselves. We also don't want HTTPS only. If a user wants something else, we should give them something else. That's just fine. Let me see. I think the flag is on the HTTP connector builder. Yeah, it should be down here somewhere. Enable all versions. That's what I need. Okay. So sure, we can start by just grabbing the hyper website. That doesn't really matter to me. Where was the rest of this command here? I think it's up here. Yeah, so we build the client, and then it's just client.getURL, but this is a future right here. And so we need a way to wait on a future. And so what we're going to do here is coming back to what request does. In this case, we just want a single thread Tokyo runner, essentially. And I'm going to ignore the error handling as well right now. So we'll just do .unwrap. That said, we don't need to enable all, I'm pretty sure. I think we just need to enable IO and enable time, which again, this is related to I want to see what we can save if I really push the limits. We also will need Tokyo as a dependency for this to work correctly. Once we build it, I think we can, let's just make it a variable. I think it's just runtime block on is what they used, or something along those lines. I think Tokyo should have to do it here as well. They're making their client. Client.execute. Oh, they're doing a proper like Tokyo spawn. I think we just need runtime.block on though. We're not doing anything fancy. I think we can just do this, though I don't know if that'll actually get us a result. I feel like there's a more correct method here that I want. What does this need to be? Oh, it would help if I had a semicolon here. Okay. We obviously need Tokyo, so it's not surprising it's an issue. This is just saying we're not using things, so let's just remove them. That should be fine right now, for now. Why is this not telling me an error? What's the error? It says there's an error, but it won't tell me why. Okay, cool. That's really useful, Rust. Language servers are just fine. So there we go. No method in scope with this. Interesting. What else do I need to import? I thought their example was like a complete example here. Always good when their direct example has issues. Do I have to import some trait? That's normally what it means. I need like TLS acceptor. What did it say for traits? Found HTTPS connector builder wants TLS config. I'll wait a minute before I deal with this. See if it's just some import that's not being happy. The other thing that we need is Tokyo. And again, I'm just going to steal the line from here. I'm pretty sure they have a Tokyo. Yeah, right here. Just with net and time. And again, I think that's all the features we need. And 1.0 is fine. They're at 1.0.37 or something. And so that should be fine. Now if we reload this. Oh! And both complaints go away. Yep, I thought that complaint was weird. So we block on this. Does block on actually return the result? Or the result of the future? Like, can I do that? Does that work? I assume so. Okay, cool. And then we're just gonna debug print it. Oh no, we need something that'll be in result. So we'll error print it for now. And this should be enough that we actually see what this pulls in dependency-wise. Because if we error print it here, it'll have to stay in the final binary. So we'll just do this. And then we'll still have it panic with unimplemented, even though it gets this far. But that should require it to pull in all the dependencies that we need. So if we now build and measure the size... Oh. Dependency issue. Oh, apparently our cross term has a dependency on something. And... something else has the same dependency at a slightly different version. Okay. Can I just, if I just like let this upgrade itself, will it fix my issues? Don't really want to fight with it right now. Let's make this bigger. Okay, so we have Mio. Tokyo requires 0.89 versus cross term 27 requires 0.8. Interesting. Is there any newer version of cross term that I can update to? So I thought it should auto grab the newest version. No, this is the newest version. Ugh, dependencies. Always so much fun. Okay. So I guess we can try using an older version of Tokyo until this works. I don't know how much that matters, but if we just go back a few versions and see if that works. I'm surprised given I didn't specify the version that Rust can't figure this out. Let's just try 30 and pin it to exactly 30 and let's see if that plays nicely. Oh, it's 1.30, sure. Okay, cool. That works. It's an old enough version of Mio. Whatever. Doesn't matter too much to me whether or not these versions are exact. But let's see what the size is. Does request actually use that much wrapping around hyper? Or is hyper just as bad as request? Like, is that really the issue? Because, I mean, this is still pulling in TLS. It's pulling in the HTTP framework. It's pulling in an async runtime. So it may just very well be that we're kind of stuck either way. Oh, hey, this error came back. Interesting. Wants TLS config, but with native roots is supposed to give it the TLS config. I thought that was the whole point of with native roots. Let's go back to those docs, because they make a new one. Oh, there's this use. That shouldn't matter. If this matters, I'm gonna be a little annoyed, because they have new with TLS config with native roots, and they should be implemented on wants TLS config. Is this... Oh, there's a config builder extension with native roots. I may need to import that. Let me see if that's a thing I can just import. Yeah, let's try that. That's a trait that maybe is missing. I'll just throw that here. Is that what we're missing? No. Okay. The other idea I have, it's supposed to turn into a config wants schema. And this is implemented for config wants TLS. New gets you one, and with native root should have it. That's quite strange. I mean, I can try this one. I mean, first off, let's just try importing this. I don't know why that would make a difference, but just in case. Oh yeah, unused import. That's kind of what I expected. I don't expect that to work because that shouldn't have pulled in any new traits, so that should still be broken to my understanding. Yeah, okay, exactly. Let's try those other roots. What were they? Web PKI? I don't think that's what we want, but let's at least see if it compiles. Okay. Next plan, let's double check what request does, and see if there's something silly that we're missing. Go to request here. We should just be able to search and look for the connector builder in request. Nothing. Okay. What was it? It was hyper rust TLS. Okay. Oh, they actually provide their own TLS. Interesting. Let's see. HTTPS connector from HTTP and TLS.clone. So they provide their own Rust TLS to it. That seems like it should be unnecessary. But yeah, that's how they specify their different TLS versions, I guess. It's not particularly useful to me. I'd have to like track down exactly how they create their TLS and then pass it in. Let's see, inner is an enum. That's not going to tell me about anything about how it's defined. Oh, here's Rust TLS being defined with TLS, and TLS is getting cloned from something else. That's not useful. Rust TLS client config. Okay. I wonder if I just need to import Rust TLS or something. Real quick. Let's try that first. If we go back to I don't know why a hyper rust TLS wouldn't automatically add this, so I'm a little confused. Oh, you know what? I'm probably doing something silly here. I turned off all its default features, and it probably needs one of those to actually pull in its own Rust TLS. So if I do that, and I let it have default features again, and now we build. Yeah, now it's pulling in Rust TLS. Okay. So that was just them trying to avoid certain features. That makes sense. So I should look at the features of this crate and later cut them down potentially. Because I guess if you provide your own TLS, you don't need it. Though it looks like it's pretty clear, their default features. Like we probably don't need logging or accepting, but we're gonna probably want Tokyo and HTTP1 and TLS given we're running with Tokyo. Oh no, that still doesn't fix it. Oh, okay, just enable all versions not found in current scope. Okay, different error. We have fixed the first error. Let me go back to their docs and double check that. Go back to the H2S connector builder. And it should have... So this is on a wants protocol. I should make sure I didn't accidentally reorder a thing. Enable all versions. Maybe it's just a typo. Oh, that didn't copy. So useful. Oh, it's because I'm on my Linux machine. That makes sense. SSH failing me. Doesn't automatically merge my clipboards. I guess we can also jump back to their example. Oh, because they did HTTPS only, and I got rid of that. So there's some other flag I need to use. Yes, I'm missing one build step. There we go. Allow both. Now this will probably build. We have a wants protocol 1, which I think wants protocol 1 is what had enable that. Oh no, this is a wants protocol 3. Wait, do I have to like go one at a time? Oh no. This is on wants protocol 1. We have enable all versions. That is literally on a wants protocol 1. HTTPS connector builder wants protocol 1. HTTPS, well, oh, this is just connector builder wants protocol 1, but still. Oh, now do I need that extension thing or something that I deleted a second ago? Let me real quick undo and grab that again. Go back to what I had and throw this back in. Is that an extension? No, it's not. Definitely a bit strange that this isn't just working by itself. Because we know we have a protocol 1. Oh, do I need the HTTP2 feature explicitly? Was that not default? Ah, yeah, that would do it. Thanks. That's one of the things that we have to decide is if we even want HTTP2 as a feature for basic CLI. I've just kind of assumed we want both because this can be faster for certain use cases, but I think right now it's really just for grabbing web pages, so it probably doesn't matter. Okay, yep, that was totally it. Last piece needed. And let's see what size we get. Does this actually save us from what request had? I'm hoping it at least saves like a megabyte, but it may just be that 100K that Cargo Bloat said. It depends on how many other transient dependencies we just wiped off by directly calling with Hyper. And of course, I'd expect this to save extra because we're not using a number of features, so more things can be garbage collected. Versus once we add in all of the different like get and post methods and things like that, that may add a little bit more bloat to the binary. Definitely taking a long time to link, which is intriguing. And this is why we have a surgical linker, so you don't get to stare at a linking screen for however long. To be fair, this is an unfair comparison. It has LTO. Oh yeah, that is a nice gain. So we're at 2.9 megabytes instead of 3.6. So that seems quite acceptable. I think that's worth actually committing to. Save a little over half a meg in the final binary. And maybe someone can come and prune features and save a little bit more later, or I can try that a little bit later. So we end up not needing that. And then this is all good now. And so now really all that matters is kind of dealing with all of the mapping stuff that was done before. Let me shrink this back down. So yeah, we had all this mapping before that kind of deals with timeouts, deals with mapping errors, just saying network error for initialization problems, things like that, mapping get and post methods, etc. And so we should be able to map all of these, but I've never used Hyper's request library, so we'll see exactly how hard that is. I'm assuming this is all stuff that goes on the client builder here, or maybe not all of it, but a lot of it probably is. I wonder if we can just see the methods for it. Let's go back over to the docs. It's probably the best spot to look at this stuff. So the client APIs, we have to make sure we're not on 1.0 because 1.0 doesn't have all the features yet. It's actually kind of annoying. Apparently they're trying to change some of the APIs to make it safer and whatnot, so it makes sense, but it just means that certain APIs are now just missing, which is quite inconvenient. Because client just calls against a URL, so I'm hoping we can, add a lot more than just getting a URL from it, and make a full-featured thing for it. So we have the builder, which returns a builder. I'll open that new tab, and then client has just get request. Oh, request is where you build a proper request. Cool, let's start with that. And I get that it won't be the exact same request type as we had, but it should be mostly the same. So I'm gonna just start with some of these pieces and just moving them over and then trying to correct their types to the hyper equivalents. So I guess that'll all go in here for building the request. So all of our glue things, instead of going to the request version, does hyper just expose method, or is it like hyper client method? Let's see, where's a request? I mean, it's hyper request. Oh yeah, hyper method, cool. So if we just change these all to hyper, does that hopefully will just directly work. Probably because request was actually just doing like a direct mapping. Yeah, cool. So that's nice and direct and straightforward. The timeout is probably a client key if I had to guess. So if we go over this builder API, there's probably, yeah, idle timeout defaults to 90 seconds. Is that what I want? No, idle sockets being kept alive. No, that's not it. Let's see if there's any sort of request timeout. Okay, this is keep alive timeout, pool idle timeout. No. Okay, so these are all like client side timeouts and not sort of the same thing as a request timeout. So we'll have to double check where that comes from. Oh, it might be on Tokyo itself if this returns a future. It may just be Tokyo saying, hey, do this, but with a timeout. So we'll ignore the timeout for now still. What does that leave next? Oh yeah, they just kind of map errors to network errors for now. I guess we can also do that instead of, where was our unwrap here? Yeah. Both for the runtime and actually I think this was for the client itself. So let's just do, I don't know if we have a better error message, but for now, even if we don't, that's fine. Oh shoot, I don't have my Helix config to get rid of double characters. I forget what the way to do that is. Okay, anyway, that was a mistake. Copy that. Do it for, I guess, both this. Oh, the HTTPS builder just works. Okay, so it's just for the client. We'll be changing this to be a match. So I think we can also do Unwrap or else. Oh no, but that takes a inner function. That wouldn't work. Okay, yeah, never mind. Okay. So we'll just keep that the same. Oh, is this... It's not a result for some reason? I removed the unwrap. Are you sure, Rust, that this is a... What did I unwrap if this wasn't a result of some sort? What do I need to do, like a 2 result on this? That seems unlikely. Okay, well, just let's see if building clears that. Expected client HTTP blah blah found result. That's a weird error. How do you expect a client, not a result? What? Oh, is it because of this? That something's just being weird? If I like delete this, will it? No. Okay. How did me unwrapping this give me a result? How does it think that's a result? Here, real quick. Okay, whatever. I don't want to mess with this too much right now. We will just leave it unwrapping for the moment being. That's a really weird error. Oh, it literally didn't have an unwrap. I'm just blind. Okay. Doing work that doesn't exist. Okay. Yeah, that makes sense. Okay. So we have the method mapped. They use a request builder to deal with all of the headers and whatnot. Because they request with the... Oh, I guess the request just has a URL. Wait, do they not use the request more? No, they do right here. Yeah, with the headers and whatnot. So they get a request builder from the request method. We'll have to see if that's the case for ours or not. Because I think we have to build the entire request and pass that to the function, right? This is building, yeah. We just make our own request builder. That's fair. We define its method, its URI, etc. Okay, yeah, so we can do that. Is it that? Ah, no. Close enough, though. Okay, so we make a request builder. On it, we're going to be setting the method as method. Then we're going to set the URI. Wait, is there a URL method? Can I just set the URL and call that good? Probably not. Yeah, we have to do the URI method, which means we have to do that parsing. Oh no, it can just take a string too. URI can just directly take a string. Cool. Do we have a body on this request? I'm assuming rock request has like a full body and everything, right? It is, yeah, body, timeout, and we've used the URL and method already. Body, timeout, and headers. Cool. So I think body, we're probably just doing the same thing as below. We're just like getting bytes, and you know, I wonder if this just ports now that we have the request builder. Let's just try that and see what we get as a result. So we just put this all here. Does that just work? Not quite. It'd help if I put things correctly. Okay. Okay, most of that just works. Expected due to this value. What is expected? Let's see what this error is. It found a result of a request evacuate and a error. Oh, it looks like body just kind of is the build command. Once you apply the body, it returns the result to begin with, it looks like. Yeah, expect right after that. Cool. So in that case, we'll just not do that here. Instead, what we'll do... is we will make this return the body bytes. And in the else case, we can just return an empty slice. Is that what that's going to be? That's my assumption. Oh wait, we actually we convert it into a vec. What is body byte list? This is probably a rock list then, right? Is this a rock list? It is, okay. So let's instead make this return a rock list. Should be empty here, yeah, cool. Oh, and then I have to put the body byte list here. Given we have to turn this to a vec anyways, actually, let's just do that on the inside. And later this can be optimized, but for now, we are just paying the cost of fully converting it to a vec. Theoretically, there should be a way to avoid that. And in this case, this is just an empty vec. There we go. And so this body command is what actually fills things out, and so that's what we need to match on that's equivalent to this build here. So we can again just copy this along. And so this is where the body command goes. Also, I'm going to rename this just to body bytes here. Okay. Oh, missed an S. So that's the next part of actually generating the request. We don't have the timeout yet. I guess that's a question. Is the timeout on this request builder? So dot timeout. Gotta love when autocomplete just decides not to work. Okay, let's just go back over here. I'm assuming this does not have a timeout on it. Pull ready, call. Oh, this is like, I need the builder. I'll pull this, yeah, builder's here. Oh no, this is a client builder. Need hyper request builder. Yeah, request builder gives me a builder. And the builder, does it have anything with timeouts? It does not. Version URI extensions. Interesting. Ah, that gets you a reference to the headers it already has. Cool. Okay, so yeah, it doesn't deal with that, but that's okay. It probably means we have to deal with it on the Tokyo side, as I thought, like Tokyo does timers and whatnot, so there's probably something I have to do there where I say, hey, Tokyo, please fix things. And so now this is just request. Request. And so this has no timer yet. Oh, it expected a request hyper body found request evacuate. Okay. Can I just do... Okay, what is a hyper body? Let's just look that up real quick. Body, because it can be whatever type we want the body to be. Okay, sure. So let's see. Request body. I don't see the definition of hyper body at all. That's kind of interesting. Weird. Oh, I'm on an HTTP crate. That makes sense. I jumped crates. Okay. Hyper body. What a name. It's the hyper body. But anyways, what? So we have hyper body empty. Can I just do an into from rock to the hyper body? Probably not. Probably be a little bit more work. Say what it actually is. Oh, it's a stream of bytes. Okay, that makes sense, so that you don't have to deal with it. Deal with things. Okay, we're gonna not use hyperbody for now. Again, that's another optimization someone can make later. But I'm pretty sure hyper will gladly take evacuate instead of the body. And in fact, can I just do... that. I'm not sure that'll actually work. It probably will complain for some other reason. Yeah. Many complaints. Okay, let's try then the vec u8 and see if that plays nice. Is Rust capital? No, it's not. That's Rock. Rock uses them in capital. Oh no. Okay, no, never mind. That doesn't work. Okay, so let's figure out how to convert correctly. Can I just do a .into? That would be my preferred way to not deal with this for now. What are the chances that just plays along happily? Oh, do I have an old... I do have an old URL that should go away. Okay, that's fair. It's still complaining. Oh, this is totally something different. Okay, so maybe we're good then. Okay, that looks like it's compiling. Cool. And this is getting closer to having the full features, right? So we have the actual full request being defined. I think the only thing... Like, obviously, we need to then take that request and generate something with a response, right? Which is probably what all of this is, and hopefully we can just port this whole thing over as well. Because I'm assuming it should have the same types. I don't think response does anything special. These are all just HTTP requests, right? So actually, if we just uncomment this and delete all of this middle stuff besides the timer, because I need to remember that I'm still missing that. And delete this unimplemented and that printout. And then here, I guess we can, yeah, we'll leave that separate because it probably needs to do something with the timeout anyways. So we just put that. Do the types happen to work out? Not quite. Okay, but most of it is just working out. But I think bytes isn't here. We just saw this on body. What was body's thing? It was 2 bytes. So we just do 2 bytes there. 2 bytes found for struct response in the current scope. Oh, it's probably body.2byte, right? I don't see a body. These seem weird functions. I think it's not pulling in what it should be. My language server, not playing nice. Normally Rust language server works pretty well, so I'm actually a little surprised like that. Yeah, 2 bytes not found on reference to hyperbody. Oh, really? Now that we have the body, that's a little surprising to me. So if we search up response here, hyper response. Oh, into body. You have to take ownership of it to get the body. That's fair. I don't think we need it anymore, so that should be fine. So then we should have the hyper body, which still doesn't have 2 bytes for some reason. So into body, we now have an owning version of the body, which we defined as a hyper body. So then why is hyper body not okay? Oh, come on, go back. There we go. Oh, body 2 bytes. It's the easy thing sometimes. Does this always work? That would surprise me. Oh, it's a future, isn't it? That's what it just said, I think. So I think we need to do runtime.block on again. And then it probably still doesn't quite work. Oh, they're hyper body bytes. They're not normal U8s. That surprises me a little bit. In fact, let me look at this 2 bytes function and this aggregate function. Oh, because it's giving me a stream. This is still a stream. I need to put it into a vector or something. So they await it. Oh yeah, I have to deal with an error of some sort. For now, again, just gonna unwrap the error so I can move forward. I'll think about what the correct error type is later. Okay, there we go. And then I guess if it is a bytes, bytes is already an iter, so I can just do that. Yeah, that seems to work. Cool. Then I guess their error doesn't have isRequest. What does it have? Nothing, because my language server is being a pain. Yes, I get there's an error, language server. Can you tell me something useful? Okay. What is the type of error? Oh, a hyper error. That's nice and simple. Is a parse error, is a user error, is a connect error. Oh yeah, there's a ton of different error types. Cool. So I'm assuming most of these we can actually just directly think. So a parse error is a bad well, no, a parse error is not a bad request. That's a bad response. This is a lot of different possible issues. Is user, is canceled, is closed, is connected, it's incomplete message. Yeah, so I guess is timeout is the one we deal with correctly. I feel like all of these we probably can just map to something there, but maybe what are the specific network error issues? So I guess, yeah, is connect is very clearly a network issue. Is canceled and is closed are network issues, I'm pretty sure. Oh no, the request was canceled. So we're not canceling any requests, so that should never happen. So is connect and is closed probably can be considered network issues. The rest of these are probably not. Okay, so we'll do that. And then we'll just swap these. Because those seem to be the main network errors. And let's see, are we still at our 2.9 megabytes? Hopefully. So we've at least saved 700 kilobytes, which is kind of nice. And then I guess the last thing I should just start prepping is I think for the timeouts, I'm going to need Tokyo to deal with them. I guess I can search it here, see if anything comes up for searching timeout. I mean, they have a timeout error. Oh, right here. Hyper client connect HTTP connector. Set connect timeout. Oh no, these are all like sub timeouts. Connect timeout, keep alive timeout, header read timeout. Yeah, there's so many sub timeouts. I guess I could set them all to the big timeout. Because I want to do this is like well, that's the HTTP request timeout. I guess connect timeout is the main one, but also downloading timeout. I'm a little surprised there's no more specific thing here. But yeah. Because we're just doing a single request, so there should be nothing with keep alive related to this. And I doubt it, like I want the full body reading timeout, really. Oh, I guess the request can't timeout there because it's if this is when the body reading happens, is all the way down here. Ah, that's an interesting problem. Okay, let's see how to do a timeout in Tokyo though. I'm pretty sure I can just start a timer and then like make everything that blocks wait on either or. If I recall. Rust. Hopefully that gives us a little bit better. Yeah, Tokyo timeout. Let's just go to the Stack Overflow. It's obviously Stack Overflow is always correct. Oh, my document's not automatically on. There we go. someone talking about their code. Then we get the timeout example. Yeah. Ah, cool. That's a nice, simple way to do it. Yeah, I feel like that shouldn't be too bad, besides the fact that we have like 2 different timeouts. So I guess we need to wrap this all in like one giant async function to make this work correctly. Because we need both things to use the same timeout. So first off, let me grab this timeout. So yeah, this is definitely a little bit more inconvenient, I guess is probably the best way to put it, dealing with the timeout. But we will take this and we will return maybe time limit, I guess. Which is just this duration. So that should be the time limit for everything after this point, essentially. I'll need my let. Yeah. Oh, we need an else, and I don't know how I want to do an infinite timeout, so we'll just do an option for now. Cool. Okay. So we have our time limit. And so basically, if the time limit is some, we want, like, if there is a time limit, we want to do something here, and if not, we want to just move on with our lives. But they have, let's see, can I wrap this all in an async lambda just to make things simpler? That's a terrible name. That's the wrong syntax. What's the... I've been doing too much C++. Oh, man. Literally can't remember the Rust syntax. It's just the pipe syntax. Yeah. Okay. And can we just move everything into this? I forget how that works. I know there's a way to just tell it to move everything. Move. I know there's some extra thing I need to say for it to like capture everything. Yeah, we'll wait. It'll come up in a minute, I'm sure. But for now, we'll just not make it capture anything and instead just go like this and put this entire block inside. Need a semicolon there. So we've defined this ginormous function, which already had a proper return type. Also, I guess we don't... no, that's fine. I'll leave it be. Well, it's not complaining at me yet. So can I just say... Oh, but I don't know if this will be async. I need to put an async keyword in front of that. So I want this to be an async lambda. No, that's not how this works. Oh, async closures are unstable. Use an async block. Oh, wait, can I do this? Does that just work? Oh, that's cool. Because I think that's what I need, and then I just need to remove all of these extra things here and add the dot awaits. And then where is the other block on? Oh. And then again, just dot await. Should probably complaining because I'm not returning anything. If I have this async thing, then I can just do... I don't know if this is going to work. Let's see, but we'll try it. Runtime.blockOn. Because it's not a function, so I don't expect me to like pass this as a function to just work. I guess the result is actually what we want to return. Yeah, that's what I thought. That doesn't just work that simply. Because even though this is an async block... Oh wait, that's just an error with a time limit, because I'm not using it yet. Sure, let's ignore that for now. Yeah, still 2 errors. What do we got? Oh no, those are outside of this. Okay, those are other errors. So maybe this does just work, which would be pretty darn awesome. Let's test. Yeah, cool. That looks to be compiling just fine. And if that's the case, then doing this time limit thing should be pretty simple. Oh, I scrolled way too far. So basically, we just match the time limit. And we just do if it's some limit, we'll do whatever that Tokyo timeout function was. And if it's none, we'll just do what I've already done here. But for now, so we can just paste that there. That should all be happy. I need like a comma and a comma. Yeah, perfect. And so now we just need that runtime timeout thing that I had opened a second ago. Too many tabs now. Don't know where it is anymore. Ah, here we are. Yeah, we're on it. Okay. And they're just awaiting this, and so instead, we'll get it as a result. So we're going to block on this with HTTP. I guess it's a block, but whatever, that's fine. But that is the wrong type. Yeah, perfect. And so we'll just match that. And either it's going to be okay with a response, and in that case, we're just going to return the response. Otherwise, we should get our timeout, which will just be an error of some sort, but they're all timeout errors now. And so in that case, we want to just do the glue response timeout. So there's a few different timeouts, technically, but I'm fine with that. And that should be this function ported. Oh, except here is the limit. Okay. So that should be the limit. And now we should have a saved 700 megabyte-ish binary with a fully working HTTP function. That definitely took a little longer than I expected it to, but I think that should be fine. I guess there's still the body error that needs to be handled, but in general, this function doesn't really handle errors quite right yet, and I'll clean that up later. Let's see, do we still have all of our savings? Gotta wait for LTO. Let the computer think. But I think we should still have all of our savings, so that's actually really nice. Like, totally a worthwhile amount of savings for not that much work, just switching to a lower level library. Yep, there you go. And, you know, this still isn't, you know, 700 megabytes or, you know, whatever crazy tiny things you can do with C or whatever, but, you know, given I know that basically 2 megabytes of this is literally just for this HTTP handler, which eventually will be properly using the async runtime. Right now it's all just blocking and whatnot, but there are things in the work that will enable it to not just be blocking, and it'll actually use the async runtime. And so then the cost feels more reasonable when you get the async runtime with it. Because like right now, I bet most of that space is the async runtime technically under the hood, but we're paying for it and not using it. But yeah, I think that's fine. So I guess next, I know Luke specifically requested that I look at the basic web server platform. and try to do some similar things to it, though I just want to do the high level stuff to it, so hopefully that'll be pretty quick, because to my understanding it's ginormous right now because it's just missing out on the really big important core pieces. And so let's just jump over to that and see what we're actually dealing with. Oh, do I not have it downloaded on this computer? Oh, I don't. Okay, that's fine. Let me get rid of a number of these tabs. Just clear out a little bit, because none of this stuff will affect it. I mean, yeah, we can copy and paste this code block to remove request from it, sure. But I think you said it's still in the, like, crazy 100 megabyte size problem stage, right? So if that's the case, there's much bigger things to fix first. But yeah, if it's just this code block, we can definitely just, you know, once it's cleaned up, copy it over, and that's no problem. But anyways, let me just go double check real quick. Basic web server. Yeah, that's the address. Cool. There we go. Yeah, okay. Okay. Now we have the basic web server. Get to see how terrible or decent it is. And so just to begin with, let's build an optimized example here. What are the examples in this folder? We'll just do the echo example. Let's see how, what's our base state? How bad is it? And this will take a minute. But yeah, let's just run that and see what we get. What's our base state? How bad is it? Is it gonna be just like, oh, it's 6 megs and we want to do the same sort of fixes? Is it gonna be 100 megs and it's just missing like the core changes that are super needed? I'm thinking it's gonna be at that smaller size. Oh, Luke says greater than 100 megabytes. Oh boy, let's see what this generates. It shouldn't be greater than 100 megabytes because it's a Rust platform, and all the Rust platforms should have the garbage collection now. So that definitely surprises me. Okay, let's see the moment of truth. What was it? Echo? Oh no, it's only 16 megabytes on my machine at least. Maybe that's not, you know, perfect, but you know, it's not 100 megabytes. This is on a Linux machine. Maybe there's some weird glitch going on with Mac, but I think it means it at least has the basic garbage collection in Rust, and we're not breaking any of that. So let's start with a super simple big trick that's going to make it way better, which is just to change Rust build settings to not be so bloated. And we're going to copy this from... What? Which folder am I in? This is... Okay, we'll just do it this way. Okay, so projects, rock, basic... No? Is it? Oh, rock, miscellaneous on this computer, because it's the older one. Rock... basic CLI, open there, cargo.toml, source, cargo.toml. Okay, that was a little bit much. But if we just do this, just do the basic stuff that like every distributed Rust platform should do. Let's see what we save just with that little bit. Also, Luke, I'd love to get a confirmation if it's still that bad on your Mac machine, because I mean, I am on Mac. I can like stop running on my Linux machine, and that would be interesting to potentially look at. Did I not just create this? Is this on? Wait. Oh, did I just like pull this into the wrong directory? That's why I'm so confused, because this is in rock basic CLI rock basic web server. Oops, slight misfire there and where I put it. That's okay. For now, we'll just deal with it, and I will correct that later. Okay, on your Linux machine last night. Interesting. Okay, so we have 8 bytes, 460 kilobytes, 103 megabytes. Yeah, interesting. I wonder why yours is so ginormous. And that's like a clean rebuild. I wonder if there's something missing. Oh, when was the last time you compiled Rock? That's an important question. If you have too old of a version of Rock, you're missing the changes to do actual garbage collection on the Rust binaries. And that's very important. Compiled from source last night. Weird. Why do we have such different numbers then? Okay. I have at least maybe one minor theory, but I don't think it should be affecting this. Anyways, let me add this and then run for now. So we added that. Let me do the rock build command again. And so this will recompile the platform again, which will take a minute. So there is a chance, and this is where I always get confused. I'm pretty sure ls gives me the raw numbers of bytes correctly, but I run on a system that runs compression by default. And so sometimes when I'm running commands, I run the wrong version of the get me the size of a file command, and it tells me the compressed size instead of the uncompressed size. So there's a chance that this number that we were looking at is actually 19 megabytes compressed. But I don't think so, because I think du-hs is what actually tells me the uncompressed or the compressed size. I think ls gives me the uncompressed size, but we can verify that in a second and see if they give me the same answer. If so, oops. If so, I'm worried about basic CLI even more if it was giving me the compressed answer, but that is possible that that's what's happening here. Either way, these changes, you know, I guess that means if I thought I changed only like 700 kilobytes and that was 700 kilobytes compressed, maybe I actually saved like 2 megabytes, which, I mean, is better, but the fact that we have to save 2 megabytes is just a horrible baseline if that's what's happening. But really don't know at this moment, so... LTO is really thinking with its web server platform, huh? Oh, there we go. Oh, that's not what I wanted to hit. Okay. So if we look at this example, it says 3.8 megabytes, which is basically exactly what happened with basic CLI. So now we're basically the exact same size as basic CLI before my other optimization. But real quick, let's see if I'm about to be really sad. Let's see, is this... No, yeah, so there's my compressed size. So it's 1.9 megabytes compressed, 3.8 uncompressed. Okay, I was a little scared that I was looking at the compressed size and we're about to see some ridiculous number. There's still a question of why my number is so much better than yours in general. But at least I'm now less afraid that like I was just looking at compressed numbers the entire time, because that would be really sad. That said, more file systems should do compression by default. Like, half this file size is just gone. It's so nice. You know, I basically just magically have double the disk space. On top of that, it actually loads files faster, because disk is really slow. It's much faster to uncompress in memory, like to load the file and then uncompress in memory, than it is to deal with all these, loading that extra data. But yeah, so it's basically exactly identical in size. Oh, huh, that doesn't sound right. That really doesn't sound right to me that the changes would have happened overnight, because my garbage collection changes are like a month old now. I think. They're at least like before we started streaming at all, so like at least 2-3 weeks old. So I really don't know what's going on with that. Anyways, we can actually, I guess, just copy over that same function also. You guys have so many more features of Hyper. Oh, and you already have Tokyo with a multi-threaded runtime and all this other stuff. But we can just delete that, paste in. I guess we just need Rust TLS here. Yeah, you guys enable HTTP2, so I'm going to also enable HTTP2 here. And then once we have that, we can also just go into the lib folder here, or lib file here, and look up request again. Okay, I'm not feeling this song. Give me 1 second. We're apparently in the what's considered hip hop according to this playlist thing. Let me switch to something simple. Okay. Okay. Anyways, if we go and we find request, oh, is it not in this anymore? Oh, I think there's a separate, what, HTTP client file? Yeah. Here we go. And so they just have this send request function, which is basically the exact same thing, except with like internal request and internal body and whatnot. Given this is just the same work, but slightly different and like a little bit of extra coloring, I'm probably going to leave this for now because I think it'd be pretty boring for me to just copy and paste and then just work on, oh, what's the different type name? So I will leave this be for now, but I guess we know that we can save, what is it? I guess another half a megabyte or so, 700 kilobytes or whatever. So for now, I'm going to ignore that part of the change and just add this. Oh, did I change the dependencies somehow? No, I'm just going to ignore those for now. Okay. Oh, we need more ignoring files, apparently. Okay, let's just do all of the additions real quick. I'm not going to change the cargo lock. I will leave that to someone else. Because I never know if people care about their cargo lock dependencies or not. Okay, so we'll just add that. So we're just changing the Rust release profile for small binaries. Oh, I probably don't have permission to do this, do I? Nope. Okay, I'll have to set up things later to deal with this. Or just send the code to Luke and let him deal with it. Oh, that's not where I wanted to go. Okay, well, I'm at this. Let me quickly close this, exit that window. What is this? Oh, it's old stuff. Okay, and then let me clean up my folders real quick. So it's rock basic CLI / rock basic web server, and we're moving it to rock basic web server. Okay, so those directories are cleaned up, and then let me make my commit for rock basic CLI real quick. Okay, so this one I will have to take the cargo lock because I deleted a dependency. So let's just directly add the cargo lock, and then let's check everything else. Okay, so we got rid of request. Oh, I can re-add in that exact versioning for cross terms. I don't know why we do exact versioning. I'm not really actually a fan of that. It's a little weird to me. So for those of you who don't know, what I'm talking about is the fact that they decided to put equal signs here. And so that means you have to get exactly that version, if I understand correctly, versus either deleting it, which is equivalent to putting the caret there, which is saying you have to get something that is compatible with that version. And so in this case, it would be to be compatible with 0.3.69 would be 0.3 point anything here. And so this is essentially saying 0.3.x, you know, fill in the blank. My music was getting dramatic. Yeah, I don't know all this music yet. By the way, if you ever decide to do anything and you need DMCA free music, Stream Beats by Harris Heller is really awesome. he has a metric crap ton. It's like 50 gigs of music, and there's most of it's lo-fi like this, but there's hip hop, there's hi-fi, there's some different other things, and it's just meant to be background music for streams and videos and situations like that. And so I highly recommend it. It's great. Like, I can just take this with the music, upload it to YouTube, not worry about copyright strikes. It's really great. Anyways, given this currently uses equals, I will not fight it. I will just obey the current situation and just use equals for all of these. And I guess I should check if I can upgrade this to 31, because I think it was only 32 that I couldn't upgrade it to. So let's see if that works. We'll just do a quick cargo build to see if it works. Oh, I need to be in the source folder. Let's see. Okay, dependencies are happy, so we can go all the way up to 31. Cool. Otherwise, it should have complained because it does dependency checking right at the beginning. Okay, cool. That was all I wanted to change there. So continuing on. Oh, of course, there's more. Let's have the cargo.lock again, because I don't want to deal with it. Okay. So got rid of request, changed it for hyper and rest TLS. I guess if we switch to native TLS, we'd save a little bit more size, but it wouldn't be a static nice binary in the same way. Formatting stuff, we'll just ignore that, not add it in. Here's the main function, now using hyper instead. I don't think, I mean, it might have slightly more crash cases that I'll have to double check on later and make better, but that's all the change. Cool. That's a bit long of a name for the, I know the Git UI is not actually that long, so names cut off when you make them too long, but that's fine. Okay. And so I think that actually covers the first two main bullet points, right? Well, one was already done right at the beginning. But two here, we now have basic CLI updated, and web server, it looks like all of the same things can just directly be ported. I don't really feel like dealing with that right now. I might make a PR later. Otherwise, I'll, pass it on to someone working on basic web server, because it's easy for them to just drag in what I just changed here. So what time is it? It's 1:30. I can at least explain the base of this next piece here. I probably won't stay streaming long enough to really give a super detailed to actually dig into it or really work on it a ton, but I can definitely explain it. So let me try to do that. This is actually finally jumping back into the the rock code base itself. So if we go into rock itself, we can just start here. So what's the best file to start with? Do I start with Excalidraw here? No, probably not. Okay. I think it's this bitcode file is probably the best thing. Okay, so I'm just going to try to explain this because it's a little bit hairy what I want to do next. So one of the things that they always say, sorry, this is the wrong way to start this. Okay, so one of the things that Andrew Kelly, I remember, he told, I think, Richard, and Richard has repeated many times, is you really are a compiler engineer when you realize that llvm does not handle calling conventions for you. So there's the C calling convention. It's like standard on frickin' every system. It's how like FFI works for everything, and llvm wants nothing to do with it. llvm has a label that says, hi, I'm using the C calling convention, right? Which is probably the C call cob right here that we see in the top corner. It's actually a little cut off. And you can see this is llvm's internal calling convention marker, this fast call cob right here. But that is all llvm knows. It just has this label. It's a label, nothing more at all. It doesn't help you at all. It doesn't try to just generate the C calling convention for you, even though it's like well defined on every single platform, and llvm deals with lowering to every single platform. llvm just doesn't deal with calling conventions. And so it's left up to the language implementers, every single one of them, to re-implement the C calling convention. And, you know, pretty much everybody needs CFFI, so everybody ends up re-implementing this calling convention over and over and over again. For your internal stuff, you can use fast calling convention, and fast calling convention will kind of let you do whatever the hell you want and will optimize it some. And so that's nice. But when it comes to calling into C functions, you're just sorry out of luck. You better implement this right or you'll hit bugs. And in our case, it is implemented mostly right. Right enough that you can use Rust, or you can use Rock with the Zig built-ins, and that works. It just works, no one thinks about it, and it's fine. That said, to handle it, we have a couple of special cases. Our special cases are specifically around 3 different types. There's the list type, there's the string type, and then there's the decimal type. And the decimal type is different than the other 2. So lists and strings are just these bigger types that end up being made up of 3 different pieces, right? And so they end up needing to be passed by pointers some of the time, and other of the time they're passed directly. And then the deck is actually just a U128 under the hood, right? It's an 128-bit, or I guess signed integer, so an I128. And the issue is, depending on the system, it might be passed in registers, it might be passed as a pointer, etc. And so these different types here have different rules about how they need to be passed. And so when this was first worked on, I think Folkert was the main person who implemented a lot of this stuff. And the big thing that they ended up doing is they made these functions called like call bitcode function, right? It just directly calls. It assumes everything's gonna work. This is like the underlying thing that just basically is saying, hey, link to me this, or I'm trying to call this thing, find the symbol and let me make a call instruction. But then we have, you know, oh, what if it doesn't return anything? Okay, so we need a slightly different API for dealing with that, sure. But then as we dig into this, it ends up getting more complicated. Like, oh, call the bitcode function, but fix for the convention because, oh, we're actually doing some things slightly wrong, so fix those problems. And then if we keep going down here, this is, you know, our transformer that deals with fixing some of those problems. But the main functions that I'm interested in, let's see if they just come up as I scroll here. No, they're not. Okay, so let's see. So what is it? It's call bitcode, or call, sorry, list. Oh, list. So there's this call list bitcode function. It's pretty straightforward. If you have a function that has a list, you tell it what the lists are, and then you tell it what the other arguments are, and then it just deals with calling, right? So problem solved. There you go. Lists dealt with. And then if you have any guesses as to what function I'm going to look at next, call a string bitcode function. And there you go. Same thing. You tell it what the strings are, and it fixes the calling convention for you so that we handle strings correctly. And you can see that it's like actually dispatching on the architecture here, right? So on, you know, 32-bit systems, we have to do one thing. On 64-bit systems, another. Technically, there can be times where the C calling convention is different between ARM and x86. And when you get to the most painful things, you have things like, oh, well, the macOS ARM calling convention is technically different than the Linux ARM calling convention, and that can cause bugs for you. So it can be a mess, simply put. But yeah, so we have this for lists, we have this for strings. Those functions both work, solve a lot of our problems. And then finally, we have all of the deck-related functions, which for whatever reason, I think, oh, that's not it. Oh, it's not actually in here? Called deck? No, it's not. This is ref count decrementing, so this is a different thing. For whatever reason, I guess deck is in another place. I think it might be in like low level for some reason. Let's see. Yeah, so here's our, like, we actually grabbed Zig's version of the deck type instead of figuring it out ourselves, for example. Still not seeing the actual underlying definition here. Oh yeah, here we go, yeah. Build deck unary op, and then there's build deck binary op, and these deal with all the special decimal handling. What you may or may not have realized yet, this is what I want to fix, is we have a function for lists, we have a function for strings, and we have a function for decimals. What if I have a function that takes a list and a decimal? Well, in the current world of Rock, if you have said function, you have no solution. You make a new custom function, essentially, that handles just that function specially, because you can't use the list version because it'll handle decs incorrectly, and you can't use the dec version because it'll handle lists incorrectly. And surprisingly, this has not fallen apart in any major way yet, despite the fact that we have to use lists and strings together pretty commonly, and we have to use decimals and lists together pretty commonly, or decimals and strings, right? When you're converting to and from decimals and strings. So this actually comes up pretty often as a thing that needs to be done. But we've managed to either have little special cases to handle things. I think, for example, the list built-in function now handles strings also, so it really should be build list and string function, right? But anyways, this is overall just kind of a mess of split up handling all over the place, and it's not a fun time to work with at all. And so that's really what I want to come in and fix up. It's been on my list for a long time, and really where this is most important is we really want to get our Windows support better. And lo and behold, Windows C calling convention is different than other C calling conventions. Who would have guessed that Windows would do its own thing from everybody else? Sounds pretty standard. But anyways, because Windows has its own special calling convention, it's most likely to run into problems here and break. We'll get an error where llvm will be like, oh, you told me to call this function with this signature, but it has some other signature. What do I do? Made worse. This problem is made worse by the fact we're using Zig. Only a little bit, though. I'm not trying to say using Zig was a mistake. I think it's a great language for our built-ins, and I love it. In fact, I think the whole compiler could be in Zig, and that would also be pretty cool. I think it being in Rust is just fine as well. But, I like Zig a lot as a language. The big problem in this case is that they've had some bugs and changes in their calling convention implementations. I know WASM had a ton of issues that they recently did a whole update and fix on, but we basically had the case where before we had to work with all the Zig workarounds for WASM's calling convention, and then when they fix their issues, we now have to update everything to use the correct calling convention. And I think the same thing just happened to Windows with the decimal type. I think their C++ compiler generates a decimal as 2 U64s, but apparently their new Zig compiler generates it as 1 I-128, which then means that it's passed as a pointer apparently, which actually that still sounds wrong to me. So I think they may still have a bug in some calling convention stuff on the Zig side. But nonetheless, this is... Oh yes, that's another big one, right? In a short time, llvm is finally changing the alignment of 128-bit integers to be 16. So, if you are an integer that takes up 128 bits, you should have an alignment of 128 bits. Now, as I commented a little bit before, I'm not sure if I'm sold on this change, because we're on 64-bit machines, and they load in 64-bit chunks, so 128s don't really have an 128-bit alignment. They only have a 64-bit alignment requirement. But nonetheless, it really should be 128. That is definitely the correct answer, even if implementation-wise it would be okay for it to be less. Which is also historically why it has been less, because originally 128-bit integers were first represented as 2 U64s. Actually, they were maybe even represented as 4 U32s before that, right? And so because of this legacy reason, they've always had this wrong in llvm. Needless to say, you can see there's a lot of pieces that come in and come together here for how we represent types at the calling convention level and at the border. And so fundamentally, I just want to make some sort of simple central dispatch to deal with this, right? Whenever we're calling a bitcode function, a built-in, right? We know what it is, right? We know this is list 2 UTF-8 or whatever, right? Or string 2 UTF-8 that converts a string to bytes, right? Like we know exactly what all of these functions are. There's no ambiguity, right? None at all. And so that means we know the types of every single variable for all these functions. And so what I want to do is basically make a central dispatch where when you call a bitcode function, you pass it all of the types of each variable. So you pass it the variable and the type. And then it can go through and it can say, okay, this one's a list, that one's a string, this one's a U32, etc. And it can go through and then do the correct full calling convention spec for all different systems. And so by pulling these all into one central dispatch, one, there's now just one place to update. But two, we're actually getting all of the information we already have and just exposing it to the compiler to depend on. Instead of this weird call list built-in where we pass in a list of lists, or call string built-in where we pass in a list of strings. And the other issue with those functions that's related to their API, if we go back to the build stir, build list. Wait, call, not build. Call stir. Yeah, there we go. So the other issue with these functions, because they have strings and then they have other arguments, they expect that all the strings come at the beginning, which is generally true in Rock, right? Generally the main type, byte, string, list, etc. is at the beginning, but that's not guaranteed in all APIs forever. And so this just has a number of issues that end up being problematic overall. And so this is definitely going to be a bigger project, a bigger organizational thing of the code base of trying to make it so that instead of passing something like this, where we're passing multiple lists and basic enums, we'll have one core call bitcode function. It will be typed. So instead of taking basic enum, it will take something where we specify the types. So either it'll be a list of types and a list of basic enums, or probably I'll make a, enum. I'll make a Rust enum that wraps basic enum. One of those two, essentially. Or just a struct, because they're all just going to be basic values, right? But probably just pair them together because that's more convenient. Though maybe not. We'll see. Either way, this is the base idea, is getting all this type of information that we already have, exposing it explicitly, and then making it so that we can get rid of all this special handling and unify to one main location. Related to this, I wonder if I can find this real quick. Yeah, I think it's this. Return value, call, and load. So one of the things they did to try and help deal with this is we have this type information-based dispatch, but only for the return value. So someone realized, oh shoot, I have a problem. I can't have a list function return a string or a string function return a list because they're different types and it's messing up with my current dispatch. And so there's been this partial solution for the return type deal with this. That said, this is still incorrect. Because if you notice, it's a list of string or basic, but what did we just talk about? Well, we talked about the fun type U128. We're missing it here. And, if you're on Windows, it's going to be dealt with differently than on Linux. At least that's what I believe Fulkert said. And so we're still hitting issues here because basic is too basic. It doesn't include all of the special cases we care about. And so for me, I will probably try to put all of our core primitives. Rock doesn't have that many, right? Whether it's the record, the tuple, the actual different integer types, etc. And we've actually defined these in the compiler at different places. I may be able to reuse a lot of our regular typing information, right? So there's this thing called layout. That I wonder if this is the right version of it. Let's see. I think this is in layouts, which is slightly different. No, this is the wrong version of layouts. There are multiple things that are called layouts. It's a little hard to show just directly. No, that seems right. Wait, where's the actual layout struct? Layout interners. No, this is a different layout than what I'm thinking of, I think. Oh, no, it's right here. It's just that it now has a new level of indirection that I didn't realize. Okay. Yeah, so right here, we define actually all of the types that Rock ever sees, period. From the disk standpoint, like the actual byte standpoint, right? So we have our built-in types, then we have the different versions of aggregates and fancier things. And so if we go to built-ins here, you can see we have ints with different wriths, floats, etc. And so like most of what we need really, I think, is just going to be using this built-in type right here to specify the type, right? If we have this much information, it's plenty enough. Now we might need to use something slightly different because we probably don't have access to all these in layouts here and we don't care about them anyway. But fundamentally, it's the same idea. And so by switching to something where we explicitly specify this type of information, we'll be able to do a proper dispatch and really clean things up, hopefully. And then it'll be much easier to make custom code for the Windows C calling convention and the Linux C calling convention and the macOS ARM C calling convention. Though I don't know if that actually is a difference we have to handle. I think that's just a register difference, and I think that's handled by llvm. So that might be a case where llvm actually handles it, because llvm does deal with the final register level differences of these platforms. Oh yeah, I guess it's just the different x86 calling conventions on Wikipedia. But literally just when looking at x86, it's kind of crazy how many different calling conventions they have, which I just find like just kind of crazy in general. Like, look at all of these different things that people have had to implement multiple different times in different compilers because of different pieces, right? So for example, I think Windows doesn't use the C calling convention. They use fast call, if I recall. Oh, no, they have a thing that replaced it. Yeah. It's the Microsoft calling convention, right? So we have to make sure we implement this correctly. We have to make sure that we implement the System V calling convention, and then we have to make sure we implement the ARM calling convention correctly. Oh, and WASM, of course. But nonetheless, all of this we have to handle, and so I want to organize this all into one nice, basically type wrapper, and make it so that we can do all the dispatch in one place as opposed to all of these different caller functions all over the place. And so that's going to be the goal for the next stream, but I don't think it's a good time to start it now, so I think this will be more or less the end of the important topics for today. I guess anybody have any final questions or things they'd like answered, top of mind, comments, etc. Also, just a quick shout out if you're ever interested. I'm assuming most people are on this already, but there is a rock chat that you can join, rock.zulipchat.com. We're very friendly there. We love getting more people into the language, both for just messing around with it, but also for people who actually are working on the compiler. There's just still lots of work to be done. But, you know, it's definitely a nice community and a fun time. So if you're ever interested, come by and join. But with that, thanks everybody for watching, and I'll see you in the next stream where I guess I'll be tackling all the fun llvm stuff. That stream will really get into what real compiler development is to me, like the stuff that I end up really picking at versus some of this other extraneous stuff that I still quite enjoy, but it's not compiler development in the same way, right? We worked on a platform. But yeah, thanks for watching. I'll see everybody around.